Hello, everybody. Can all of you hear me? All right, good. So, hello, I'm George. And today we're going to talk about hiding some very sensitive information within our application, pretty much in plain sight. So, let me talk just a little bit about me. As I told you, I'm George Kortsaridis. I come from Greece. I am a graduated software engineer from the University of Western Macedonia. I'm the organizer of the GDG Thessaloniki chapter. And I'm also working remotely for a company called Glidewell Laboratories, which is located in California. So enough about me. Let's start talking about what's the actual information that we need to hide. Well, it's pretty much every single line of code that we have inside our application. That includes Java source codes, resources, so manifests, strings, layouts, dimensions, colors, drawables, extra modules, so it's like Wear modules, TV modules, Glass modules, everything. Third-party libraries, so any kind of third-party library that we're actually downloading in order to use, that's also not safe. That means that everybody can decompile our application, they can change the code, and then recompile it back. Today we're gonna see some very simple ways we can actually guard our application in order to make it more robust and harder to hack. So I'm gonna start with some numbers. Over here we can see the top 100 paid and free applications, both on the Android and iOS Play Store. And these numbers tells us two things. First thing is that, as you can see, the paid applications are much higher risk, hacking risk other than the free applications, because as you can imagine, if you actually hack a paid application, maybe some money are involved inside of it, so paid applications are much higher risk than free applications. The second thing that this tells us is that mobile developers don't have security as their #1 priority, maybe not even the top 3, maybe 5, or something like that. So that's why I'm here today, and I'm going to tell you a few things that might change that. So I'm going to split my talk between two parts. First part is going to be the offense, and then we're going to talk about defense. I'm starting with offense because in order to realize how you can guard your application from hackers, first you need to know how somebody can harm our application. So there are a few ways that somebody can actually hack our application, and this is like the simplest one. We begin with GPS mock locations. Everybody knows that Android operating system gives pretty much everybody the opinion to enable mock locationing system and fake the device's location to all over the world. Let me give you an example. Everybody knows Pokemon Go over here. It came out a few years ago. Everybody downloaded it. And there were some people who actually wanted to catch Pokemon without actually do the walking. So what happened was that some developers created some tools that actually spoofed the device's location all over the world, so they were actually did the walking without doing the actual walking, and they were catching Pokemons. So silver lining is that when we're writing Android applications natively, it's very easy to actually check whether the mock locationing system is on using this single line. So please, everybody who uses GPS input within their applications, do that. Add this single line of code within your application. It's going to make it even more harder for plenty of hackers to hack it. Next, I want to talk about the network layer. So the network layer could be, I don't know, maybe a totally different, separate 45-minute talk. But right now, I'm just going to go over the top of it, tell you about the general rules, and I'm going to let you find out the rest of you by yourselves. So everybody knows that when our application is using the internet layer, pretty much what's happening is that we're sending something into the internet, and then our web server responds with something back, right? So the bad thing is that there are plenty of tools like MIT proxy or Wireshark that can actually spoof this internet traffic, so they can find out exactly what we're sending into the internet and what the internet is sending back to us. And there's a problem because when we add this with a man-in-the-middle attack, they can actually change everything that's going on between our application and the internet. That means that we send A into the server, but that somebody makes it like we sent B, or we receive something like totally different other than what we just received within our application. So what we can do in order to protect ourselves from that? First of all, please use HTTPS protocol. HTTP is dead. everybody who's having something to do with a web always use HTTPS protocols. Second thing that you can do in order to add another layer of security within your applications is actually implement some kind of authentication system. There are so many authentication systems out there which are free. There is Firebase, there is AWS Cognito. You can also implement your own authentication system. And if you add this, you're going to make it even harder for a hacker to actually create a man-in-the-middle attack. So, it takes some time, takes some effort, but if you do that, it's going to make it even harder for somebody to hack your application within the network layer. Next, let's go to the actual APK decompiling part. That's like the main process of, this is going to be the main topic of this talk. So I want to tell you two things. First thing is that every single line of code that we're writing within our application can be decompiled. So always have that in mind. Second thing is that I want everybody to know what an APK is. Do you know what an APK is, other than the actual executable file for an Android? Well, actually, it's a glorified zip file. It's a compressed file. So there's no security into it. There's no nothing in it. It's just a compressed file. So how can somebody decompress our application? Once they got the APK file, they can use a free tool that's called APK tool. And once they do that, they can very easily get access to the manifest, the resources. So we're talking about layouts, strings, dimensions, drawables, and all of that. APK tool can give us access to the actual source code, but not in the form of Java files. It produces some files called small files. It's not the exact Java code that we're writing, but as we'll see later, if we read it line by line, we can understand pretty much what's going on in there. Although, if that is not enough and we want to go even deeper and get the actual Java files within our application, then the only thing we can do is rename our application from .apk to .zip and then decompile it. And then, decompress it. So once we decompress it, we can get access to all the manifests, the resources, the drawables that I mentioned before with APK tool. But instead of getting access to the actual source code, we're having a file called classes.dex. So this file can be easily translated from a DEX state to a jar state. There are plenty of open source tools that can do that. I prefer the DEX to jar. Oh, the battery's dead? All right. Can you hear me? All right, good. So, where was I? All right, so everybody will find the classes.dex file in there, and they can use plenty of tools. I prefer the DEX to jar tool, which is open source and free to everybody. And they can translate the DEX file to a jar file. And of course, once we get the actual jar file, then everything's very easy, very simple, because there are so many jar decompilers out there where you can actually see the code, change the code, and recompile it back to jar, then from jar to DEX, DEX to a compressed APK file, and boom, you have a hacked application. So as you can see, it's very easy for somebody to hack us. So over here, I'm going to take a pause, and I'm going to have an actual decompiling demo. OK, let me minimize that. And I will open this folder. Oh, OK. Let's do, yeah. All right. Good. All right. So we're going to have a demo right now. As you can see, I'm having two things in this folder. I'm having an APK, and I'm having the DEX to jar folder. So the APK is a very simple application that I created. It's created of two screens. The first screen is a welcome screen, and then there's a button that takes us to the second screen. So, it's no big deal, but I created just to show you how easily we can actually decompile that and see the exact code that I wrote. So what we're going to do, we're going to open the terminal. Let me take it down. It's ready? OK, give me a second. Great. So what I'm going to do is I'm just going to use APK tool, which is a command line tool. And I'm just going to write APK tool, D for decompile, and then I'm just going to give the mobile.apk. I'm pressing enter. I'm leaving APK tool to do their job. And then just in a few seconds, we're actually going to have a decompiled APK. So APK tool is done. And going back into the security folder, I'm seeing that there is another folder that's called mobile. So from mobile folder, I can see that I'm having plenty of stuff. I'm going to open Atom and go into the mobile folder. Again, you can't read anything, so let me try to do that as well. OK, first things first. You see that I can get the Android manifest file, which is the exact file that I wrote. As I told you, there are two activities. First activity is the main activity, which is the launcher. Then I'm having a super secret activity. So boom, there you go. Android manifest is over there just with a single click. Next, let me go into the resources folder. And inside the resources folder, you see that there are so many folders that were auto-generated from the Android system, but always the code that we wrote is over there as well. So we begin with the animations folder. I don't have any animations myself. All of these are Android-generated animations. But if I created something, it would be right here. We're having colors, again, Android-generated. Let me go into drawables. You see that there are so many actual Android-generated drawables. But if I know where to look, I find that this thing is not Android-generated. This is an actual image that I inserted inside my application. And it's over there. It's right here. I can make it. I can take it. I can change it and put it back. So our images are not safe either. Let me continue into layout. Again, plenty of Android-generated code. But if I know where to look, I can find the activity main.xml. So you will see that inside my application, the activity mail is nothing else but a relative layout, a text view that says, let's see, you got me. Then I'm having an image view with an image that I showed you before, and then a button that says start something new. And on click, I'm running a start super secret page method, which we're going to see later. And if I open the activity super secret, again, you can see that it's nothing else but a linear layout with an image view. So our layouts are not safe either. Going back, I'm going to open the MIPAP folder as well. You can see that all the icons that were generated for my application are right there. Now I will open row folder. And inside the row folder, you will see that, hey, this application had a where module as well. So I can take the APK from here. I can do the whole decompile process. You can't read it, but it says Android where micro APK. So I can take this APK and do the whole decompiling process again to get the whole source code for the Android where module as well. Now I will go into values. And again, I'm getting the whole values that were written from my Android Studio. That means we're having attributes, bools, colors. So this is like my color accent, my primary dark colors. I'm having dimensions. Again, plenty of Android-generated dimensions. But if I had any dimensions myself, that would be here. Any drawables, IDs, integers, blah, blah. Let's go into strings. Now I'm going to take a pause here. I'm going to show you the whole Android-generated strings. And I'm going to go down. And I want you to take a look at those two strings. So please, everybody who has something important in their strings, take it out. I've talked with developers who have credit card numbers inside their strings folder. Major mistake. You might understand why. So yeah, if you had something important that's inside the strings resources, think again. Maybe encode it if you want it to be there. But please don't leave it exposed like that, right? And I'm going to end up with styles, which is over there as well. Now, there are plenty of values folder. Those are like values for separate languages. And deep down, there is an XML folder with the actual XML file for my wearable application. That tells me again that I have a wearable application. My wearable has a version code of 1, version name of 1.0, and the row path resource ID. So closing from the resources folder, I'm going to go into the Smolly folder. So the Smolly folder, as I told you, has all the source code that was used inside my application. that has both my code and any third-party libraries, but it's in Smalley type of code and not in Java. So I'm just going to start opening the folder. So we're going com, George Kortsaridis, hack me now, and I'm getting all my Smalley folders, all my Smalley files. But I'm going to take a pause here, and I'm going to go into the other folders. As you can see, OK, there's the com Google folder that's unregenerated. But I can see that there is the com Square App Picasso folder. That means that my application is using the Square App Picasso library. So everybody can tap into that library as well. So not third-party libraries. They are not safe as well. Now going into the hack me now and main activity.smalley. We will start reading this file, but as you can see, it's not the exact Java file that we're all used to. But we're gonna start reading it line by line, and we'll see that it's gonna start making sense. So we begin by a class. There's a public class with the name of main activity. The super is app compat activity, so it extends the app compat activity, and the source file is called main activity.java. Then we're having the instance fields. The instance fields are the variables. So we're having a double variable, so a D, which is amount of money. I'm having a string, which is called community, another string, which is name, and a string, which is surname. Then I'm going into the direct methods. So first, we're having the constructor, which is unregenerated. It's nothing to do with my own code. And then I'm going to my own methods. So first method is private, and it's called getAmountOfMoney. It returns D for double. And what it does is that it creates a constant wide, which is called V0. This V0 constant has the value of 23.0123, and then it returns the V0. So it's just a getter for the amount of money. Then we're going into the get community. Again, it's a private string. It creates a constant wide V0 of GDG Thessaloniki and returns that constant. The same for name. Same for surname. Now let's go into the virtual methods that are the actual methods of the system. Of course, we're having the onCreate method. And first things first, they are revoking the app compat activity.onCreate, which is the super.onCreate in our Java code. Next up, what's going on? We're having the set content view. So of course, we are setting the content view of our application. Next, what's going on? Let's see. So next up, we're invoking the getName method, and we're returning something into this directly, a variable which is called P0. Then we're moving the P0 result into the V0, and then we're going into the name variable and putting inside name everything that's inside the V0. That in Java is pretty much name equals getName. So that translates into these lines of code in Smalley. I'm doing the same for surname, same for community, and same for amount of money. I'm not going to say it again. Next, let's see what I'm doing. I'm creating a constant string, and OK, I'm building it, and I'm using the log. So I'm pretty much logging out the name with the variable. Doing the same for surname, same for community, same for amount of money. This is a lot bigger because I'm actually logging out the actual double number with a string. So I'm just going to end it up by talking about the start super secret page method that, as we can see, takes a parameter of type view that tells us that is the actual on-click method that we saw before from our layout. So this method, what it does, it creates an intent. That intent is looking straight into the super secret activity, and then we're calling the start activity with that intent. So as you can see, it's not exactly Java code, but we can see roughly what's going on within our application. Let me open real quick the super secret activity as well. As you can see over here, we're having only one instance field, so one variable, which is an image view. The constructor, which is unregenerated, and inside the onCreate, OK, setting the content view, finding the view by ID inside the image view. And then I want to show you how the Picasso gets called. So I'm having this thing. I'm calling the Picasso library. I'm giving the Picasso library this string in order to load an image from the internet inside my image view. So I show you this because I want you to see how easily somebody can hack into my application. But as I told you before, Maybe we're not, maybe this is not good enough, so we actually want to go straight into the Java source code. So let's see how we will do that. Let me go back into the Finder and go one folder back. I'm going to create a duplicate of my APK, and I'm going to rename it into mobile.zip. Yes, I want to add this extension. And once I do that, I will just, oh, sorry. Before I do that, I will create another folder, call it test, and pull the zip folder inside, because once it unzips, I don't want to unzip in the root folder. I'm going to go inside the test, and I'm going to unzip the mobile.zip. And as you can see, the APK, which was renamed into zip, just got decompressed. Going back into the test folder, and again, you can see that by unzipping the APK, we're gaining access into the XML file, the Android manifest. We're gaining access into the resources, again, animations, colors, drawables, layouts, mipmaps, raw files, everything's right here. And on top of that, we're having this file, which is the classes.dex file. I'm going to copy that file, go back, and paste it inside the dex to jar folder. I'm going to do the same inside my terminal, clear out the screen. So once I'm inside the terminal, I'm going to invoke this specific script. So I'm just going to call the, let me put it down here. As I told you, it's this screen, so it's d to j slash dex. Sorry, it's that one. I don't want to mess everybody up. So it's dex to jar.sh, and I'm going to give it the classes.dex file. And again, it's doing a job. Let me close that real quick. And as you can see, from the classes.dex, we got this jar file. Now I'm going to open a very simple Java decompiler. And once that's open, I'm just going to drag and drop this jar file inside of it. So again, I'm seeing that there is the Android support folder over here with the full source code. I'm seeing that there's the George Kortsaridis Hack Me Now folder. So let me open the main activity. This is a much better. Let me see if I can make it look bigger. I'm hoping you can understand pretty much what's happening in here, but we're having a public class, which is main activity. It extends Apk Compile, as I told you. We're having some private variables, which is one double amount of money, strings, community name, surname. We're having some getters for amount of money, community, name, surname. And inside our own create, as I told you, there is the name equals get name, surname equals get surname. Same for community, same for amount of money, and then I'm logging them out. And then there's the start super secret page. So as you can see, we can get the exact source code that I created, I compiled it, and I published it into the Play Store. And on top of that, I can go into the Square App Picasso library and gain access to the actual third-party libraries that were used. So for example, I can go straight into the OKHTTP downloader class and actually change Square App's library. So that's another hack. All right, enough with the demo. As you can see, there are plenty of stuff that they're out there. They are very easy to hack. So let's see how we can actually make our code more robust and harder to hack. So we're going into the second part, which is the defines part. Before we begin, I want everybody to go through the APK signing process so I know we're on the same page. So what's actually happening where we're signing, where we're compiling an application? First thing, we're getting the manifest, the resources, and the assets, and we're putting them together inside something that's called package resources. Then we're getting the source code and all the third-party libraries, and we're creating the bytecode classes.dex. I see there's a line missing there because the package resources and the classes.dex get combined together to create the unsigned APK. And then the unsigned APK gets the actual key, and we get them together in order to create the signed APK. And then the signed APK is ready to go straight into ADB or go straight into the Play Store. So that's the actual signing process that we're getting into. Now, let's have a code example in order to see how we can actually make this type of code more robust and very hard for somebody to hack. So let's say that I am a developer, and I wrote this piece of code. I'm having a method that encrypts a very sensitive message. I'm having some nuclear launch codes. I want to encrypt them with some encryption keys. And pretty much, I'm returning the cryptoengine.encrypt nuclear launch code with encryption keys. So I want you to imagine that you wrote that, and somebody decompiled it and gained access into this type of code. I think that you would be in a pretty ugly position, don't you think? All right, so what can we do in order to make this harder to crack? First thing, we're going to add reflection. So instead of invoking straight the cryptoengine.encrypt method, what we're going to do is first create a class object, which is going to be a class for name cryptoengine. Then we're going to create a method object, which is going to be the class object we created before with the get method encrypt and parameters string and string. And then we're going to invoke this specific method. So why should we do that? I mean, if somebody hacked this, again, they would be able to understand exactly what's going on in there. But let's take it a bit further and add string obfuscation. Now, with string obfuscation, instead of just giving out the string resources right there for the hackers, we encode them, for example, in this case, with base 64 encryption, and add them right there. So right now, when we're actually creating the class and the method objects, we'll make it even harder for somebody to understand what's going on in there. Now, I want to take it up a notch. What I'm going to do, I'm just going to add name obfuscation. So instead of creating a method that's called, I don't know, encrypt sensitive message, or something that's human readable, why don't I just name my method A? The nuclear code, A again, and then the encryption key, B, the class C, D, E, F, and it goes on. Then I can guarantee you that if somebody cracks that, gains access to this type of code, they're going to have a very hard time to actually understand what's going on. And that's pretty much what we want to achieve, right? So there's one thing. We can just start writing our whole applications, our whole code like this, which brings a very simple problem, don't you think? What happens if I want to change something? Or what happens like, I don't know, a week, or in my case, 5 minutes after I write this type of code? I'm going to be something like, is the A the nuclear launch code and B the encryption key, or is it the other way around? So what happens is that I can't actually work like this. So what do I want? I want to write human-readable code, and I want my code to be somehow transformed into this type of code. So what I want is automation. I want a tool that takes the code from step 1 and transforms it into the code from the last step. So this tool is called Android Proguard. Android Proguard is a tool that's pre-installed with Android Studio. It's free, it's for everybody, and you can use it. The only thing you can do is just go into your build.gradle file and just add some code inside the build type. So inside the build types for the release and the debug, if you want, you can just add the line of code that's giving the Proguard rules. So inside, I've talked with plenty of developers who are actually using the Proguard, but the problem was that they didn't actually know what was the actual Proguard rules they were using. Because usually what's happening is that you're getting a default Proguard rules file from the internet, cutting and pasting it straight into Android Studio, and then you're done. So most of the Proguard rules that are used right now are those 3 rules that I showed you before. We're having string obfuscation, name obfuscation, and the other thing that's not coming in my mind right now, reflection. So this is the only thing you have to do in order to encrypt your source code very much and make it very hard for a hacker to understand what's going on. Next thing, let's see what's going on if a hacker doesn't actually want to change our application, but he just wants to remove a big chunk of our code. Because even if the code is scrambled, they can just remove it. There's no problem in that. So what's happening actually is that every time an application gets signed again, so it's ready to go straight into the Play Store, there's a signature check that gets created every time. So there's having a signature, an SHA signature, that we create every time that we sign our application. So every time I sign a new version of my app, I know that the version, for example, 1.0 has this specific key, specific signature. The version 1.2 has that signature. So if a hacker decompiles it, changes it in any way, and then recompiles it back and signs it, then the signature is going to be different. So what I can do is just check the signature within my application and see if the current signature that's inside the application right now matches the expected signature that I know because I created and it's safely stored somewhere, I don't know, in my app or in my web server. So by using this type of code, I can make sure that the expected signature, which is the expected application that I created, matches the exact application that the user has. Another thing, let's say that you're having a super secret critical algorithm that's like making your whole application move. I don't know what would that be, but instead of just giving it straight into the application, why don't you just create an API out of it? So create an API, store it safely into the web, create a secure data communication line from your application straight into the web server, and then use that. If you do this, then even if the hacker decompiles your application, he's going to see this, this code as a black box. They won't be able to actually understand what's going on because this code is going to be on your web server. So it doesn't matter if the actual hacker decompiles that. And I'm going to close with a story. So this story is about Kevin. Kevin talked here before, and he told me that story. And he told me that once they actually created a very simple application, it was a sample application for the company he was working on, and they uploaded it somewhere, but they did a huge mistake. That mistake was that inside their application, they actually had the AWS admin key hard-coded inside of it. It was an actual variable inside their Java code. So what happened was that some bad people, some hackers, found the app, they downloaded it, and they analyzed it. And they found that, hey, this string might be an AWS admin key. So what they did is that they took this string and they put it straight into a bot. And that bot did his thing. And before they realized, their bill on the next month went up from $200, which was the usual, up to $8,000, $8,000 like this, because of a single bot. So I just want to show you that it can happen to everybody, right? And there are some people who can make our life just a bit more miserable, right? So that was it from me. I don't know if you have any questions. I'm happy to answer. No, nothing? Nobody? Crickets. Oh, OK, there you go.
Thanks. So when you enable the Proguard automatically enables then reflection, as you stated?
Yes, the first thing was reflection, the first thing that I showed you.
Does that then, but with reflection, you have the issue of performance instead of direct access to, so do you have any issue with performance of the application because you've enabled reflection?
Well, that's an excellent question. And no, I actually didn't. Java can make this, can work with reflection pretty fast. And it takes like only a matter of, I don't know, 1 or 2 milliseconds, if I remember correctly. So yeah, if you think of the actual security layer that this adds up, I think that 1 extra millisecond is no big deal. So yeah, I think that it's not like that much.
OK. Thanks.
Thank you. Somebody else?
When is Proguard not enough? There's
what?
I've heard of like DexGuard and things like that. Like
yes.
Advanced. When is Proguard not enough?
Proguard, as I told you, is a free tool. It's pre-installed with Android Studio. Although, if you want to take it up a notch, there's actually another program that's called DexGuard. That's not free, that's paid. That can do pretty much some stuff that Proguard does, and then it can add some other extra layers of protection, something like he can create an actual mapping of all the actual code and the end code. So by using this map file, you can manually decode the source code. So it adds up some, some small features to it. In my personal experience, I don't think that I've never used DexGuard, and I don't think that I will ever will, because Proguard so far works very well. So yeah, I mean, if everybody has the money and he wants an extra challenge, sure, use that. Anybody else?
So you were talking about the mock location, right?
Yes.
So just curious that there are other ways to spoof your locations, right? Like, for example, a lot of apps, or like a proxy or a tunnel.
Yeah.
Go anywhere. So have you come across any scenario where you can handle those kind of versus real location?
So other than more location system, if you use a proxy or some VPN service, I think there are some code examples that can actually find out if you're connected to the internet via a VPN service or a proxy service. So you could add this piece of code inside your application as well. So the good thing is that because we're using Java, so we're going straight into native code, Java gives us plenty of opportunities. I don't know actually if Kotlin, for example, can give us all this type of functionality yet. I'm not a Kotlin developer, to be honest. But I'm pretty sure that with Java, you can both detect a proxy connection and a VPN connection. So just as I checked for a mock locationing system, you can do the same for these types of things. All right? Next. Come on, you're getting warmed up, so don't stop now. All right, then. Thank you very much. And I will be here after the talk, so if anybody can come up to me and talk to me, feel free. All right, thank you.